Standing waves problem-solving strategies. This is a technique that works for solving all standing waves problems with the cases we looked at in this class. Alright, here's the problem-solving scheme. Alright, and we'll talk about this for a second. If I know the length of the air column, alright, I can calculate the wavelength using the standing wave pattern and knowing which harmonic I'm looking for. Alright, vice versa, if I know the wavelength, I can find the length of the air column. This is assuming that we know which medium we're in, which in most cases we're going to be using air. Okay, but we might also be using a string. Now, if we know the frequency and we want to know the wavelength, or vice versa, alright, we use our wave speed equation, v equals f lambda, alright, and our known velocity. Okay. If we know the wavelength and want to know the speed of the wave, or vice versa, and we know the frequency, we again use our wave speed equation with the known frequency. What they don't include on here is if they include the period of the oscillation, all right, in which case, remember, that's 1 over the frequency. That's a way they can make this problem tricky. All right, the key thing with this problem-solving scheme, and I recommend you figure out a way to make this make sense to you without having the picture in front of you so you can use it on the test. The key thing is the only difference in this process is what the standing wave pattern is. Whether you're looking at waves on a string, whether you're looking at a tube that's open at both ends, or a tube that's open at one end and closed at the other. Okay, so let's review those standing wave patterns. Okay, the ends of a fixed string must be nodes. The open end of a tube is always an antinode, and the closed end of a tube is always a node. And don't forget then that the harmonic number is the number of half wavelengths in that pattern. So again, to review the harmonics equations, all right, for the string, it's 2L over N equals wavelength. Same thing with an open-ended tube, except instead of nodes at the end, it's antinodes at the end. And then for a closed-end tube with the other end open, it's 4L over N equals wavelength. And in this case, you can only have an odd harmonic because you can only get an odd number of half wavelengths in your standing wave pattern.